We are going to look at the electronic circuit breakers and the trip setting, though we are not going to go into much details of the electronic circuit breaker, okay? But just for the sake of mentioning, we are going to mention briefly what is actually controlling the trip mechanism. Know that the thermal-magnetic circuit breaker, we have the thermal element and the magnetic element. But in the electronic circuit breaker, it is microprocessor based, okay? Which means that the overload section and the instantaneous trip section is controlled by this microprocessor. And then we have sensors, current transformers that are in line with our circuitry that monitors the amount of current that are flowing through the circuit. So these sensors feeds into these microprocessors what is actually happening in the circuitry, okay, as regard the amount of current. So let us look at the electronic breakers trip settings. So we are going to look at first the continuous amp rating or continuous amp setting, okay? So as you can see on the screen, the continuous amp setting is a percentage of the nominal current rating of the circuit breaker. So if your circuit breaker is rated 1,000 amps, okay, as an example, if you turn this selector switch to the 20%, turn it to 20%, that will mean that you'll be able to use your breaker as a 200 amps breaker. 30%, 300 amps breaker, 400 amps, 500 amps, 600 amps, 700 amps, 800 amps, 900 amps, and then 100% of it will be 1,000 amps. So let us assume that we want to use our breaker as a 500 amps breaker, which means we'll select this 50% of the breaker rating that we are using, okay? So what this is trying to tell us is that we can use the circuit breaker as a 200 amps, 500 amps, 800 amps, or even 1,000 amps breaker, okay? So we can vary the ampacity, okay, of or the current carrying capacity of that particular breaker. So if you compare what we are looking at now with the tripping curve of the electronic circuit breaker, this is the tripping curve. So this area is the continuous amp rating. So anything below the 1 times, okay, is within this area. So what you are doing by making this selection is either to shift this curve to the left or this curve to the right, okay? So which means that the continuous amp rating, which will eventually be the nominal current rating of the breaker at that selection, you are shifting it to the left or to the right. Are we getting it? So it means that in this area, operations within this area, the circuit breaker will work continuously, okay, without trip. Then if you go down here, this is the long time delay, okay? So this long time delay, which is this area of the curve, of course, here is the long time pickup, okay? When the current on the circuit gets to the selection you had, assuming we took 50% of our 1,000 amps breaker, which is 500 amps. It means that as we get to 500 amps, the long time pickup will be activated, okay? So now this long time delay which is this area of the curve. Okay, so the circuit breaker will delay for the amount of time you set it here if it sees 6 times the continuous amp rating. So assuming we took 50% of 1000, which is about 3000 amps, 50% of 1000, which is about 500 amps. It means that if this breaker sees 6 times that 500, which is about 3000 amps, okay, the long time delay will set in. Then when the long time delay sets in, it depends on the time in seconds that you set your long time delay. If you set it for 4 seconds or 7 seconds, it means that if it sees this amount of current, okay, which is about 6 times, that is 3000 amps, okay, the long time delay will start to counting. Okay, so any overload in this on this circuit breaker, okay, will activate this long time delay. So the amount of time that it will be delayed will be dependent on the settings you have on the long time delay. They will also have the short time pickup. Okay, so when do you want the short time pickup to be activated? This area of the curve shows the short time pickup. Okay, so when do you want the short time pickup to be activated? Look at it, is multiple. Here is calibrated to give you multiple of the continuous amp rating. Okay, so which means that if you, for example, now we are taking 5, it means that 5 times our continuous amp rating. Our continuous amp rating, which is 50% of 1000, as we earlier agreed, is 500. Okay, which means that if the breaker sees 5 times 500, which is about 2500 amps, okay, the short time pickup, okay, will set in. So the short time delay, we have two different selection or settings. Okay, here is the short time delay for 0.05 seconds to about 0.5 seconds. Then this is the I square T ramp up, okay, which means the rate at which the current is increasing actually affects the amount of time. Okay, the higher the current, the lower the amount of time. And this will happen when you have from 3000, okay, that is 6 times the continuous amp rating of the breaker. If you have about 3000 and above, okay, so all of these will set in. So what is the amount of time? 0.18 seconds, 0.28 seconds, 0.22 seconds, 28 seconds, and 0.45 seconds, okay? And as we said earlier, the magnitude of the current will determine the trip time, okay? We expect it to trip earlier if the current is very, very high. Okay, so this is the short time delay on the trip curve, okay? So here we have the short time delay, and you can see that the I square T, okay, effect comes into, that is the I square T ramp up, okay, affects this particular area. So now the next that we are going to look at is the instantaneous trip. The instantaneous trip. Okay, before we go there, look, the short time delay, you can actually override the short time delay. So you can turn this to the off position, and that will completely override the short time delay if you so desire. Okay, then this is the instantaneous pickup. What here is telling us is that whatever we select here, if the breaker sees that particular magnitude of current on the line, it is expected that it trips instantaneously. Okay, so assuming you take 10 times this the continuous current rating, which is about 10 times. Remember, we made this breaker to be 500 amps. Okay, 10 times is 5,000. Okay, so which means that if we have very high current events like short circuit current, anything 5,000 and above, we expect the breaker to trip instantaneously. So wherever we want it to behave as such, okay, on the current scale, we'll do the selection. If it is 6 times the continuous amp rating, okay, we select 6 times the continuous amp rating. Let's say we put it at 10 amps, okay, because we want to use it to protect against fault events like short circuit and any other very high current event. And this is the instantaneous pickup session of the trip curve for the electronic circuit breaker. And then we have the instantaneous trip session. So here, assuming we take this 10 times selection, here will be our 10 times, which is I3, 5,000 amps. Okay, so here will be our 10 times. So once it sees that 5,000 amps in the circuit, the instantaneous pickup will be activated, and then anything above it, we expect the breaker to trip instantaneously. So next, the one we are going to look at now again is the ground fault pickup. Ground fault pickup, okay? So you see that we also have the I square T ramp up, okay? Then here we can take a percentage of the nominal current rating of the circuit breaker. That is the actual rating, not the continuous amp rating of the circuit breaker. In our case, we said our circuit breaker is 1,000 amps, okay? So if we are taking this 20%, that will mean that we are making the ground fault pickup to be at 200 amps. So if it sees that amount of current in the ground circuitry, of course, it is expected that the trip, the ground fault protection should be activated. You can see the short time pickup of the ground fault, okay? And this is the delay, okay? So anything above that 200 from this setting, okay, you'll see that it will activate the delay and then it will trip off. And you see that the amount of time it will delay is about 0.1 second. Okay, so after 0.1 second, it is expected that if that ground fault persists, it should trip off. Then you see the range on this part of it, okay, is between 20 to 70%. We also have other range. If you make your selection on this side, you see that the trip time has changed to about 2 seconds. Also on this side, 20 to 70, the trip time also have changed to 0.4 seconds. So anything above or anything at and above half of the nominal current rating. In the case of our circuit breaker now, the rated current is 1,000 amps. Remember, the rated current is different from the continuous amp current that we selected. This is the rated current, okay? So if it is 1,000 amps, it means that half of it is 500 amps, okay? So at any fault current on the ground that is up to 500 amps and above, you see that the I square T ramp up will set in, okay? So as the magnitude increases, the amount of time will drastically be reduced, okay? So this is the area, okay, that you have it. So here is equivalent to, it depends on your setting, okay? Assuming we have our selection here as it is now, 20%. So it means that here is about 20% of the nominal current rating of the circuit breaker, which is about 200 amps. Are we getting it? So all of this selection helps us to mold the characteristics of the circuit breaker to suit our particular need as we need them to operate in the circuit. So like we said earlier, you are adjusting the continuous amp rating, you are shifting this trip curve of the electronic circuit breaker either to the left or to the right as you so desire. So this is the actual circuit breakers and actual circuit breaker the way you see it in real life, okay? So this is the continuous amp rating as we discussed before for you to set the nominal, that is the operating current of a circuit breaker, or to change the nominal current of the circuit breaker or the rated current of the circuit breaker. This is the short time pickup, instantaneous pickup, and the ground fault pickup. Okay, so remember we said it is a microprocessor base, and this is the current rating of the circuit breaker. So as you are adjusting this, this will be give you a percentage of this. Okay, so if you take 20 as it is here now, or 50, adjust it to 50, it means that you are using the breaker as a 200 amps breaker. Are we getting it? So this breaker have an added feature, okay, which means that since it is microprocessor based, it helps to store events that are happening in the circuitry. So still on trip settings of your low voltage circuit breaker. So these are where you set the tripping, okay, as we have discussed before, all the trip settings that we discussed before. So this is it, okay, for the continuous amp rating, short time delay, head fault, long time delay. You understand? So it's just to put your screwdriver and you see the arrow direction and make your adjustment, okay? So we want to look at the electronic circuit breaker, the one that actually uses a deep switch. Okay, so if you look at this, you see that it is somewhat different from the one that we have been seeing before now. Okay, so this is the continuous current rating. Okay, so you see is this will give you multiple of the nominal current rating. So the nominal current rating of this particular circuit breaker that we are looking at is, as you can see here, is 2000 amps. Okay, so we can set this. Okay, we can change this to give us a different continuous amp rating. So if you look at it, this is the dip switch. Okay, so this dip switch is telling us I maximum equal to the nominal current rating, that is the maximum current 1 times. Okay, now here, if you want to set it at 40%, that is 0.4 times the nominal current rating, it means that these 3 buttons should be down. Okay, then if it is 50%, 0.5 times, these two first buttons to the left will be down, and then the one to the far right, the third button, should be up. What this means is that if I want to use this circuit breaker, I want to set the continuous amp rating to be 50%, which is 1000 amps. Okay, from here I can see that I will adjust this first 2 down and then this one up, which is this first 2, I will leave it down. Then this dip switch, okay, the third dip switch, I will switch it up. Okay, that will give me 50%. So to that is to fine tune or to make it to be more sensitive, I can add values, okay, which is also a percentage of this nominal current. So if it is 50% we want, that is 1000 amps, I will leave these two at that, leave them down, switch them down so that it will be 0. So I will have 50%, which is 1000 plus 0. So which means that this one, I will switch it up to have my 50%. Then these two, I will leave them down to give me 0. But if I want to add a fine value, say maybe 0.05 of 1000 amps, 0.05 of 1000 amps. Okay, sorry, of 0.05 of 2000 amps. Okay, that will give us about 100 amps. Okay, if I'm not mistaken. So that will now, if you add here, you take this setting, that is, you take the first this switch up and leave the other one down. That is, you take this one up and leave this one down. It means that we are adding 100 to the 1000. So it will now give us 1100 amps as a continuous amp rating. Okay. So this is for the time delay. Okay. The long time delay. So you see, for 3 seconds, all the deep switch will be down, which means this 3 will be down. Okay, it means that overload will be sustained after 3 seconds. It's expected that it will trip. So for 12 seconds, the last one, the third one, which is this one, we need to switch it up. Okay, that will delay it for 12 seconds. So for 72 seconds, this first and the last one will be up. That is, this will go up, this will go up, and then the middle one will be down. That is, this will be left down like that. Okay, so that means we will allow the delay for 72 seconds. Okay, then here we have the short time delay. See, you can override it when all the 4 is down, it is off. Okay, so the short time delay is also what you expect it to see before the timer will start counting. This is multiple of the nominal current rating. Remember, the nominal current rating of this breaker is 4000 amps. Remember, not the continuous amp rating. This is the nominal current rating. That is the rated current of the circuit breaker. So assuming that you want it to start counting at 5 times, okay? So this is 5 times. The first one will be up, the other 3 will be down. That means you will push this deep switch up and leave the rest 3 down. Okay, that means at 5 times, which is 10,000 amps, the short time delay will start counting. For how long do you want it to count? So we have 0.1 seconds, 0.2 seconds. Assuming you want it to count for just 0.2 seconds before it trips. It means that this first 2 will be down, or the deep switch will be down, and then this last one will be up, which means this last one will push it up so that it will delay for just 0.2 seconds. Okay, so this is for the instantaneous strip. Instantaneous strip. You can override it when all the deep switch are down. So if you want it to trip instantaneously at 10 times the rated current or nominal current, okay? So that means the first one and the third one will be up, the second and the fourth will be down. First up, third up, second and fourth down. Okay, you see that there is no delay. So once it sees that amount of current, it will trip instantaneously. So the level of ground fault, the amount of leakage current that you expect to be in the ground, okay, that is what we set here. And then for how long you want the delay to be there before it trips. So that is how you do the trip setting of your electronic circuit breaker. Okay, here you can download it with the connector. Here you can download all of this information for further analysis. Remember, the breaker will store all of this information, okay, of what happened in the field on the circuitry in a microprocessor, and all of them will be stored for you for further analysis.